Hi guys, in this one, let's take a look at finding a partial derivative by the definition. So imagine we have a of xy, and this is equal to xy. So what is this thing? This is a function. It represents the area of a rectangle, say, because x could be one side and y is another side. So you have x times y. The product is the area. Okay. So we can hold y fixed, and we can change x as an example. So if you think of y as the height, and when we say we're holding it fixed, what we're saying is it doesn't change. So this is what I mean. Maybe let's illustrate with a little picture, right? This is your rectangle, and if this thing is y here, okay, it's kind of huge, but okay, and then let's do x on the bottom like this. So that's x on the bottom, and y is the vertical side. Then what you can do is you can increase, for example, in this direction. Okay, so hold on, let me grab a rectangle here. You can increase the picture, the size of the area this way. So in this case, you see, x is going this way, but the y, let me emphasize that in green, the y is held constant. It's the same y here as here. Do you see that? It doesn't change. That's what it also means to be held constant. That is, y is held constant and x changes. I suppose we could say something like this, delta x. So let me kind of emphasize this down below. Right here, you see this is our delta x. Let's keep that in mind. Okay, so now that we have some geometric understanding, let's actually work with the math here. Okay, so I'm going to do the following partial derivative. I'm going to say a sub x. That means because this has x here, it's the rate of change of the area with respect to x as the variable. That means the y is, again, going by the picture, being held constant. As you go from here and you increase x by delta x, the y is the same y. It does not change the length. Okay, so it's going to be the limit then. Now, not x, but delta x going to 0. And then you're going to, I need to zoom out, I think, a little bit. Hold on, give me a sec here. I need to be able to see this properly. Give me a sec. Okay, that's better. And I'm going to say up here a of x plus delta x, comma y, and I'm going to subtract a of xy, and I'm going to divide this now by delta x. So that's the statement, really. So it stands out here, hopefully. The relevant part is, you see, this is green, so it's delta x here. Right here, you see, this is also delta x. Okay. The y, right here, I'm going to do in red. This is y. This is y. It doesn't change. I hope you see that. So that's like going back to the picture. It's y here, and then when you move over to here, that's still y. It doesn't change. Okay. So now let's go on to the next part. I'm going to have the limit. Again, let me fix this. So delta x is going to 0. And actually, let's replace now. So I will say, because we have a function that's just x times y, I can literally just say, so x plus delta x times y minus xy. So that's just delta x in the bottom now. Okay. Then we can work through this pretty quickly. Quite straightforward. So the limit as delta x here, it goes to 0, and then I'll say xy, let me add the fraction bar. So xy plus delta xy minus xy over delta x. Now let's stop for a second. And this here, I'll make that red maybe. The red part will cancel with this part right here, correct? You see that? The two red parts will cancel. All that will remain will be the delta xy over the delta x on the bottom. I hope you got that. Now look what happens. It's then the limit here, as delta x goes to 0, of delta xy divided by delta x. But now, this here will cancel with this here. In fact, all that remains is the limit then as delta x goes to 0 of y, which is then just equal to y, right here. But that's not surprising. If I zoom back out a little bit here, go back to the top, I've already shown you in the picture, correct? Look, when x increases by delta x, but assuming that y is this dimension, y still stays at y. It doesn't change, you see that? So the area of this little extra rectangle is roughly y times delta x. Now y times delta x is like the area of this little rectangle here. Okay, so let me maybe make that a bit smaller and then flip it. You see right here. So that's y delta x. Now as delta x goes to 0, then eventually the delta x parts cancel. Okay, so you have delta x over delta x, which is like 1 basically. And you just end up with y, which is like the height of this thing in the first place. Okay, so I hope this is a bit more insightful than maybe some of the stuff you've seen before. I just want to make sure. I wanted to show you all the work from top to bottom, so this is pretty much it. I hope you can see it all. Let me take maybe this picture here and move it over to the side. Hopefully it won't crash. You see, that's the picture enlarged. if it helps you. So if this is interesting, please be sure to leave a like, to subscribe, to share this with other video who might have an interest in this kind of math. Thank you so much for watching. I'll see you in another one. And then please be sure to also check out our merchandise down below.